This is a wee video now on Pythagoras' theorem. One thing to note is that it only works with right angle triangles. So I've got one drawn on there. You'll notice a wee right angle triangle as well because it's got that wee square down in the corner of it, your wee 90 degrees. And then directly opposite that, you've got your longest line of your triangle, usually the slopey one, but it's called the hypotenuse. So you'll need to know that name. Make sure you remember that name. The other two sides of the triangle are just the legs of the triangle. But what Pythagoras' theorem has worked out is if we do squares of the two legs, then we're actually going to work out the square of the hypotenuse. That's what I mean. If I take the square of the two sides, so that's the two blue squares, then I can work out the square of the hypotenuse. That's the red square. I'm going to give these sides of the triangle a couple of numbers here now so that we can do calculations. So let's say now then that I've said that one length of the triangle is 3 and the other length of the triangle is 4, and I don't know the length of the hypotenuse. That's what I'm trying to work out. Well, Pythagoras' theorem says that if we square these two sides, so I've got a blue square here, if I find the area of that square, then that's going to be 3 by 3. 3 3s are 9. And if I find the area of this square, that's 4 squared, then 4 by 4. 4 4s are 16. And what Pythagoras discovered was if we add these two blue squares then, if I add up my 9 and my 16, that's going to give me 25. So the area of the red square has to be 25. Now how do you get yourself out of a square? You take the square root. So the square root then of 25 is 5. So the length of that hypotenuse must be 5 centimetres. So basically Pythagoras' theorem states that the square of the hypotenuse, the red square, is equal to the other two squares added together.